Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you learn how to interpret what I call a velocity graph for a given object. So very similar to my last set of videos here, we're going to talk about this car, and we're going to talk about, if we wanted to study the motion of the car, the first thing we would do is define a set of coordinates here. You can put a coordinate system anywhere you want within a problem. Okay. We've now defined a variable here. X represents the position of this car. When x is positive, the car's to the right. When x is 0, the car's about here. If x is negative, it's over here. And in my previous set of videos, I talked a little bit about interpreting the position graph for the car. Well, this time we're going to talk about interpreting velocity graphs. So velocity graphs, they don't tell you directly at first where the car is. They tell you what it's doing. They tell you how fast it's moving and in what direction. So a typical velocity graph, we'd start out by putting maybe velocity on the vertical axis, measured in meter per second is the gold standard for physics, but you could also do mile per hour, kilometer per hour, depends on the problem, against time. All right, so let's look at some graphs here. Which one did I want first here? Okay, there we go. So here's my first one. Now you might not notice this, but you notice this is shaded down here. Meaning that here's my graph. Now you notice at any time the velocity is 0. And that means the car's not going anywhere. X is not changing. All right, boring example, but try another one here. So okay, here's another example. So now, all right, at t equals 0, here we are on the graph. That position, let's see, 1, 2, 3, 4, 5. Now we are at 5, and those units are in meter per second. So what that's telling us is that at t equals 0, the car is moving at 5 meter per second, and it's positive 5, meaning that x is increasing, or the car is moving to the right. Now you notice maybe a couple seconds later, what is our velocity? Still 5 meter per second. We go all the way, no matter how far to the right I go on this, when I read my velocity off, the car's moving at 5 meters per second. So this graph is indicating that this car is moving to the right because our velocity is positive. And the rate at which it's moving is not changing. Probably enough on that one. Okay, come on, open up. That's the one we're looking at here. Okay, here we go. Here's another example. Now, at t equals 0, we're here on the graph and our velocity, let's see, we're down here at minus 1 meter per second. Now the minus sign, right, means that x is getting smaller. This car is moving left at, I think I said 1, but I meant 2 meter per second. Short time later, maybe 3 seconds, we're still moving at 2 meter per second. Again, to the left, because the actual numerical value here is some negative number. So this horizontal line is indicating that this car is moving to the left at 2 meter per second. And that 2 meter per second is not changing. And let me state that one more time. The rate at which this car is moving, which is 2 meters per second, is not changing. No matter which time I choose, I'm getting -2 out of this graph. Okay, let's look at another example here. Okay, there's one where things are finally a little more interesting. Now, always, or well, maybe not always, but most of the time I like to start by talking about the intercept. At t equals 0, we're right here in the graph, the velocity is 0, meaning that at this point in the graph, right there, the car is not moving. Sorry about my small writing there. But that's very, very short-lived. Just a second later, the car, you'll notice there is a non-zero value there. 3 seconds later, we're here on the graph, and now the car's moving at 1 meter per second. 3 seconds later, now the car's moving at 2 meter per second. I'm getting these off the vertical axis. 3 seconds later, the car is moving at 3 meter per second. So this graph is telling us that the car is moving to the right. Now the reason is because if I pick any point on the graph, I'm going to make fun of this point right here. The velocity is given by this distance on the graph, and that is a positive number. So our velocity is positive, indicating moving in what we're calling the positive direction. But you'll notice as time goes on, these distances are increasing. So at this point here, our velocity is changing. And I guess this is as good a place to introduce this as any other place. How fast the velocity is changing is called acceleration. And here's how I like to define it. Acceleration is defined as rate that velocity changes. How is it calculated? Well, it's a slope. It's equal to your change in velocity over change in time. On this picture here, if I pick any 2 points, let me choose like this point here and this one. The slope is given by rise over run, and let me color code that here. Do the rise in this pretty color here. That distance on the graph is the rise. Do this in yellow. That distance is the run. So again, this would be given by this distance. This would be given by this distance. And that numerical value, that slope, is called acceleration. Let's talk units. Your delta your change in V would be typically measured in meter per second, time in seconds. So the units of acceleration are meter per second. Or you will lots of times see that written meter over second squared. Now, when your slope is positive, it means your velocity is increasing. And the kind of reverse of that, if your slope is negative, it would mean your velocity is decreasing. So the point of this video really wasn't the acceleration introduction. It was to talk about interpreting the velocity graph. So let me go through and highlight that. These velocities increasing are indicating that the car is moving faster and faster and faster. And also these velocities being positive are indicating that the car is moving to the right. So that's probably enough on this video. I'll make more videos specifically about velocity and acceleration and how they relate to these graphs. So I'm just going to call that, oh, wait a minute. I think I had another graph I wanted to chat about before we do this. Yeah. There's another one. So let's chat about this graph before I end this video here. So intercept at t equals 0, we're here. The car is moving at 1, 2, 3, 4, 5 meters per second. But you'll notice that, about 3 seconds later, we're here on the graph. Car's only moving at 4 meters per second now. So the car has slowed down. A few seconds later, it looks like we're at 3 meters per second. A few seconds later, now we're at 2 meters per second. So this car is moving at a slower and slower and slower rate. You'll also notice that if we were to calculate the acceleration, or the slope, which is delta V over delta T, we're going to get some negative number. And the reason? Well, I'm just going to use the endpoints. Here and here. And you notice we're going down 5 and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, about 16. So if I actually calculated the numerical value, it's minus 5 meters per second in about 16 seconds. And I like decimals for these things, if you humor me for a moment. So the acceleration of this car is about minus 0.3, and we're just going to round this, 1 meter per second, or meter per second squared. Again, the point of this video series really wasn't about calculating accelerations. It was about how to interpret these velocity graphs. So let me go back and highlight that. So the intercept here is 0.5. So meaning that when we started timing this car, it was moving 5 meters per second to the right. And it's to the right because of the velocity is some positive number. And as time goes on, the car is moving slower and slower and slower. The indication of that on the graph is that these distances are getting smaller and smaller and smaller, meaning the velocity is getting smaller. And eventually we end up here, where the velocity is 0, and hence the car is at rest. So, and again, the point of these videos, we're just interpreting the velocity graphs. So I think I'm going to now seriously end this video right here. I hope that this has helped you with how to interpret a velocity graph. Have a great day.